Hello smart people, Mr. H here. In this video, I'm going to walk you through Chapter 5, Performance Task. Keep in mind that Performance Task is a little bit challenging. Make sure you take your time, read the question, make sure you completely understand what's going on there before you jump in and solve the problem. Now, if you're confused on the test, so take your time, keep going back, reread the problem, choose one thing at a time, and then until you understand the problem and try it out. Please do not give up so fast. And if you give up so fast, what do you do in 4 hours, right? So Performance Task has a theme, and all the questions that they're going to ask you around that theme. So today we're going to talk about part redesign. The scenario is people come to Wild Lake Park for many activities, but it can be difficult to get around the park in a vehicle. Mr. Miller, an architect, has been hired to redesign the roads. Currently, 2 parallel roads exist, Wild Way and Shore Street. So make sure you look at the map to see which one they're talking about. So Wild Way, that is the line that goes sideways. Okay, I'm sorry about that because I wrote on my path is not, I cannot keep it straight. So that is Wild Way, Wild Way, and then the other one is Shore Street. Here, the Shore Street. There's the 2 parallel lines. Okay, they go side by side. So which mean that there's a lot of activity, a lot of property here. You have alternate interior, alternate exterior, corresponding angles. So think about all of that. Okay, so they are intersected by lake land. So that is one of your transversal lake land that cross this way. Okay, 2 parallel lines, 1 transversal. Mr. Miller suggests to build the right road and Boat Boulevard. So we have another transversal here. What is the right road? And another one is Boat Boulevard. Okay, so 2 parallel lines and 3 transversal. That's what we're looking at right now. Okay, so think about alternate interior, alternate exterior angles. Alright, so part A. The map showed the Wild Way intersects the lake lands at 55 degrees. So this is not good coloring, so I'm going to erase all of them, then emphasize whatever I need you to look at. Wild Way intersects lake land at 55 degrees. So they talk about this angle. Find the value of x and y. The measure of the angle form when the both boulevard intersect the shoreline and lakeland. Explain how you found your answer. So it's just based on the picture. We're gonna try to solve for x and y. Any idea how to do this? You have Wild Way and you have shoreline cut by a transversal. Okay, so I wonder which angle are equal to each other. Okay. So if you say that this 55 angle, the vertical angle across from it is also 55 degrees, you're right. Beside that, you have alternate interior angles, also equal to that, is also 55 degrees. And if you want to go extra, go ahead, go to the other side, it's also 55 degrees. Yes. So in this case, we already we found out that x equal to 55 because of the alternate interior angles between transversal and 2 parallel lines. Now, so with that in mind, you have 55, you have 24.6 degrees here. How do you solve for y? Okay, to solve for y, we're going to look at the 3 angles. We're going to look at the 24.6, your x and your y. So all together, they create a linear line. So what the one is the straight line at the bottom. So as we know that linear line is a 180 degree, right? Let me try to emphasize it more. this is the angle, three angle that we're looking at that make a straight line, which is 180 degree. One of them is 24.6, the other one is 55. The third one is the missing angle. So what we're going to do is we're going to take away 24.6 and 55 from 180.6. We're going to subtract them, and 55. You will have the missing angle, which is the y. 180 minus 24.6 minus 55. That will be 104 degree. Yes. So your y value is 104 degree. Alright, if you need more time, please go ahead and pause the video to have some extra time to think about the problem. I just realized that they asked you to explain how you found the answer. So you would say x equals to 55 because the alternate interior angles are congruent. Okay. Y equal to 100.4 because x, y, and 24.6 are linear pair, or are linear angles. Maybe linear angles because in more than two angles I cannot say a pair. Okay, that's it. Part B. Mr. Miller named one of the new right road because it's formed a right angle when it intersects a short street. His business partner wants to ensure that the road is perpendicular before naming it. Use the converse of Pythagorean theorem to determine whether the right road was designed correctly. Alright, so in this case they did kind of show us all the sides here. Okay, so we tried to prove this line is a perpendicular line, which means they cut across at the 90 degree. So because of that line, we can see this this triangle is a right triangle. But we don't know for sure, so we're going to use the converse Pythagorean theorem to confirm if this one is a right triangle. Okay, so here is our triangle, which we assume is a right triangle for now. Okay, so we're going to use Pythagorean theorem. A squared plus b squared equal to c squared. Right, so who is C in this case? You have the right road is 2 kilometers. We have the boat boulevard is 5 kilometers. Okay, and we also have the shore street. In this case, is square root of 21. So who is your C? C will facing the 90 degree. C will be your 5 kilometers. C. So this will be A and this will be B. 2 square plus square root of 21 square equal to 5 square. Is that true? 2 square is 4. Square root of 21 square. Square and square root cancel each other out. Give you 21. 5 square is 25. So 4 plus 21 is 25 equal to 25. So yes, the three sides of the triangle follow Pythagorean theorem, which means that it is a right triangle. So explain your reason. How do you explain this? The three sides of the triangle which is formed which is formed from the shoreline, both Bolivar. I wonder how do you spell Bolivar? Okay, Bolivar. And one more, Wright wrote. Satisfy the Pythagorean theorem. The Pythagorean theorem. I'm so sorry. The writing on this path is a little bit hard for me. My writing is not so neat. Okay, so what I wrote is the three sides of the triangle, which is formed from the shoreline, both Bolivar, Wright wrote, satisfy the Pythagorean theorem. Therefore, it is a right triangle. Okay. Alright, please add that part. Therefore, it is a right triangle. Now part C. At the intersection of the right row and the both Bolivar, what is the measure of the angle labeled Z? Justify your response. So we're going to find angle Z. Alright, so now we know for sure that the right row is a perpendicular line, so which means they're going to cross as 90 degree. Right, so this one is 90 degree, leading to this is also 90, and this one is also 90 degree. So Z stay apart. Z is a part of 90 degree. So the question is to find Z, we need to take 90, take away that angle. How do we find this angle? So let's go back to where we did earlier. This angle is 55 degree. Our Y that we solved earlier is 104 degree, right? So this triangle can help us solve the missing angle. Okay, any idea? That will be what? The sum of three angles in the triangle equal to 180. So that will be 180 minus 55 minus 104. So that will give you the missing angle. 180 minus 55 minus 104. That will give you 24.6. Okay, so this angle is 24.6. The vertical angle across from it is also 24.6. Right, and earlier we say right row cross the Y way at 90 degree. So to find Z, you will take 90 minus 24.6. To solve for Z, it will be 90 degree. Take away 24.6. That will be 65.4. Okay, 65.4 degree. Okay, so that is the work. Justifying your response. So I can write down. Let me see what is the easiest way to write this. Because there will be a lot of writing if we try to explain this. Okay, X, Y, Z. I will call this as angle A. How about this? X, Y, Z. W, angle W. Okay. So try to think. Okay, both Bolivar and Y way. Let angle W is formed from the Y way and Boat Boulevard. Okay. Let's see. Y-Way and Boat Boulevard. We can find W. W by 180 minus 55 minus 104, which is 24.6, right? Yes, 24.6. Okay. To find Z, we will subtract 24.6 away from 90 degree. Because right road cross Y-Way as, because what did it say? Right road perpendicular to Y-Way. Because right road is perpendicular. Okay, perpendicular to Y-Way. Okay, I'm so sorry for the long explanation. If you have a shorter way to do it, go for it. Okay. All right, now we are on the back side. To help pay for the renovations, the music festival will help to benefit Wild Lake Park. The festival director, Valeria, map out the event location on the festival map. Each unit equal to 0.2 miles. Okay, so here's the map. Every box is 0.2 miles. Let me write it out so you can see it. That is 0.2 miles. Part D. Local regulation for the outdoor festival require the restroom be available within 0.5 miles of the food stands. Does the current setup fit this criteria? Explain. So the nearby restroom to the food stand is this restroom. So if you are 8th grade students, you will see this one is. You should see that we did this one on the Bellwork. I think it's exactly the same problem. So first you're gonna find the distance between the food stands and the restroom. Okay, so we can use the distance formula, or you can use the Pythagorean theorem. Okay, so this is the right triangle. The one that you try to solve for is the distance between the restroom and food stand. So your A will be 3 boxes, which is 3 units, and your B will be 2 units. Okay, A squared plus B squared equal to C squared. So that will be 3 squared plus 2 squared equal to C squared, which is the distance that we try to solve for. 9 plus 4 equal to C squared. That will be 13 equal to C squared. So we're going to do square root to both sides. C equal to square root of 13 is 3.6. So the distance between food stand and restroom is 3.6 units. 3.6 boxes, right? They ask you that it have to be within 0.5 miles. So we say that earlier we just said that every unit is 0.2 miles. So to find how many miles, you're going to take 3.6 times 0.2. 3.6 times 0.2, that will give us 0.72 miles away. So the regulation said that the restroom have to be within 0.5 miles, so half miles. This restroom is 0.72 miles, so the current setup doesn't fit the criterion. The current setup doesn't fit the criterion because the nearest restroom is 0.72 miles away from food stands. Okay. Alright, that's it for part D. Alright, we're heading to problem E. Valeria will need to travel from information to security frequently. So information to security frequently. She can ride the golf cart along the solid line from one to the other at 12 miles per hour. Okay, so which means she go around at 12 miles per hour. So that is this one. She can walk along the dash line for 4 miles per hour. She wants to use the faster method. How would she travel? Alright. So, let's see what do we have here. If she ride a golf cart, she gonna go around the lake of the right triangle. So what do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8. This is 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so if she used the golf cart, she's gonna drive around like this. That will be 8 plus 15. That will be 23 unit square, right? 23 unit square. So that, let me see really quick. So golf cart, if we use golf cart, the distance will be 8 plus 15 units, so that will be 23 units, right? But each unit represents 0.2 miles, so that will be 23 times 0.2. That will give you 4.6 miles. 4.6 miles in total. Okay. With the golf cart, she can drive 12 miles per hour. So 4.6. You're gonna find the time that she need to drive from the information to security station. So that will be 4.6 out of 12 miles. Okay, because it take her she can drive the car 12 miles per hour. 4.6 divided by 12 is about 0.38 hours. Okay, so it's less than half hour. Now if she can walk 4 miles per hour. So let's see how far does she have to walk. So that will be your diagonal line right here. So to find the distance of this, we can use Pythagorean theorem. So by walking, if she walking, we're going to find the distance by use Pythagorean theorem. A squared plus B squared equal to C squared. So that would be 8 squared plus 15 squared equal to C squared. 8 squared is 64. 64 plus 225 equal to C squared. And 64 plus 225, that will be 289 equal to C squared. And when you do square root of that, I believe it's 17. C equal to square root of that. Yes, that will give you 17. So the distance is 17 units. So to find the miles, that will be 17 times 0.2 miles times 0.2. That will be 17 times 0.2. That will be 3.4 miles. Now, definitely the distance will be shorter than the distance when you drive your golf cart around the park. So if you drive around the park, that would be 4.6 miles. If you go straight diagonally from one station to the other, which will be 3.4 miles. But what she wants to use is use the faster method, not shorter, is faster. So for the times, he can walk 4 miles per hour. So time is 4 miles per hour. We have to walk 3.4 miles. So 3.4 divided by 4. 3.4 divided by 4. So that will be 0.85 hours. So it's almost completely 1 hour. Okay. An hour, sorry. So the fastest way would be the golf cart. Okay. She will travel by using golf cart. She will travel by using golf cart. That is the faster method. Because if you want to say more, because the golf cart takes 0.38 hours to go from one station to the other station, instead of walking, is 0.85 hours. All right. Valeria wants to place the first eight station so that it is exactly 1 mile away from each stage. In what location should the first 8 station be placed? Prove that your location is correct distance from all 3 stations, all 3 stages. So 1 mile from each stage. What? Sorry, I tried. Okay, so we have forest stage, we have kid stage, lake stage. So that's the 3 stages that they're talking about. Right. Now they want exactly 1 mile. Exactly 1 mile from each state. So, let me see what can I do. This forest stage, kid stage, and then lake stage. That is 3 stages. We want to put the first 8 station is 1 mile away from each station or stage. So every box is 0.2 miles. So that will be 5 boxes away to make 1 miles away from a stage. So from, let's say, forest state, I'm going to count over 5 boxes. 1, 2, 3, 4, 5. And then over here, 1, 2, 3, 4, 5. So this is 1 mile, exactly 1 mile away from the forest state. 1, 2, 3, 4, 5. That point is exactly 1 mile from forest state. 1, 2, 3, 4, 5. If we draw a circle, I don't know if I can draw a circle here. If we draw a circle, can I write it? Alright, it's almost perfect. Alright, so any points on this circle is 1 mile away from the forest state. So we can do the same for the kid state and also the lake state. Okay, so that is that. We're going to draw the next one. Let's choose something lighter, the green one. So kid state, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this one. 1, 2, 3, 4, 5. Okay. To save time, I know this circle is exactly 1 miles away from the center. So I'm going to do copy and paste, and that will be my green, and then move it up here. Again, you probably have to draw the circle yourself, so it's going to look like this. So with that 2 circle, we know that this point is exactly 1 miles away from both Kit Stage and Forest State. Also, the point over here is exactly 1 miles, but we want this station is exactly 1 mile and away from 3 different stages. So which means we need to do the lake. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and last one. 1, 2, 3, 4, 5. Same thing. Control V. Then I can change this to pink. Okay. Oh, back. This. Move it here. Right here. Okay. And that is pink. Alright, the only intersection that 3 circles intersect at is this point. So this is the perfect location for the first 8 station. So what did it say? Prove that your location correct distance from all stages. Okay. The coordinate point is -1, 2. -1, 2 is the perfect location. For the first 8. Because it is the intersection of 3 circles which are 1 miles away from 3 stages. Alright, that's it for your performance task number 5. Thanks everyone for watching, and see you next time.